Hi Liam, hi. This is just another video of me solving randomly code problem. So there are n gas stations along a circular route. With the amount of gas at the I station is gas of I. We have a car with unlimited gas tank, and it costs of I of gas to travel from I station to the next station. You begin a journey with an empty tank at one of the gas station. Given two integer arrays, gas and cost, return the starting gas station index. If you can travel around the circuit once in a logbar direction. Return -1 if there isn't a solution, and if there exists a solution, it is guaranteed to be unique, right? So we can look at the example right here. We start at station 4, right? We have 4 units of gas in our tank. Right? To move to the next station is cost 1 minus 1, and we get 5 at the next station, right? So this is a little bit confusing because you have to add um, like I plus 1 and minus like the index at I, right? Which is like doesn't make a lot of sense here. So let me represent it in a different way. So we have 1, 2, 3, 4, and 5, right? 4, 4, and 5, right? And the cost would be 3, 4, 5, right? 1 and 2. So if you start here, right, you will have a gas of 1. To get to the next station, well, you will need like 3 units of gas, right? Which means you need to have at least 3 units of gas to get to the next station before you can even like add the next gas tank, add the next 2 units of gas into your gas tank. So like in the example, you're starting here, right? You minus 1 and you plus 5, right? But you need 1 unit of gas to get to the next station, right? Before you can even add um, the next 5 units of gas, right? So how do we know if there's a solution or no or not? So if the total number of gas, right, the total sum, right, the total sum of gain, right, is greater than or equal to 0, we know that there exists a solution, right? So the gain means like total gas, right? It has to be greater than or equal to the total cost, right? So for example, if I go from 1 to 2, right? So okay, the total gas would be how much? 1, 2, 3, 4, 5, right? Is 15, right? The total cost is also 1, 3, 4, 5, 1, 2, which is also 15. Right? So it is greater than or equal to 0. So there exists a way to do it, right? Um, and in the second example here, right, we have the total gas is 2 plus 3 plus 4, which is 9, and the total cost would be 3 plus 4 plus 3, which is 10, right? So 9 is smaller than 10, so uh, it won't be a solution. So we have -1 here. Okay. So as we iterate through the array, right, either your gas array, we can accumulate the gas rate in the car. We can just add 1 minus 3, add 2 minus 4, right? We just sum everything up to see if at the end we have a total gain of at least 0, right? Positive, greater than or equal to 0. If there isn't again, if it is negative, right, then we can just return -1, right? And again, mean the total gas need to be greater than the total cost. So how do we know when to start, right? So if we start from 1, then we go all the way to here, right? If we start from 2, we have to go all the way from here. Yes. Oh, sorry. If you start from 1, you need to go all the way, right, until you go back to 1, right? 2, right? So if we try this for every single um, node, right, every single station, it will cost us like n square runtime, and this is not good. So the question is, can we do it in one pass? So let's look at the gain, right? So we have our gas is 1, 2, 3, 4, 5, right? Our cost is 3, 4, 5, 1, 2, right? What is the gain? Our gain is negative 2, right? Which is add 1 minus 3, right? 3 minus 5, right? 4 minus 1, 5 minus 2, 3, right? So if we look at the gain array here, um, whether it makes sense to start. So we should start at the index where we should start at the station, right? We should start at the station where it will give us the maximum amount of gas, right? So in other words, we should start at the station that will give us the most amount of gas. So we can start the index on the station, the index of the maximum subarray, right? So we can see that the maximum subarray is this one, right? So we should start 3. It is intuitive because yeah, we should always start where we have we would have the maximum amount of gas. And so normally, right, we would keep track of the we would calculate the current sum, right, equal to the max, right, of the current number, right, um like yes, right, again, right, in at I, right, or uh the current sum, right, plus the next gain, right. So and then we have to update our max sum, right, equal to the max of the max sum and the current sum, right. So this is like how we would do it to find the maximum subarray, right? Starting, and we also need to keep track of the starting station, right? Starting station as well. Right? But in this case, we actually don't need to keep track of the maximum here because we know that there only exists one solution, right? If there's a solution, then it's guaranteed to be one solution, right? And we know that um, for the current sum, in order for it to be valid, right, it has to be positive. So we can just ignore the negative sum, right? If our cumulative gain at a certain station drop below 0, we can just ignore it, right? And set reset our sum to 0 and the starting station to the next station, right? Right. So in other words, if there exists only one and only one solution, and that solution must be positive, right? Which means we can just always ignore the negative gain, right? And we only keep track of the positive gain. Okay, so yeah, let's look at an example here. We can walk through this example. We can have our let's see, starting station, right? So starting station, and then our current sum and our total sum on our total current gas and total gas. So remember, in order for it to be a solution, unique, a valid solution, the total gas has to be greater than equal to the total cost, right? So we accumulate the total gas as we go. So we don't have to iterate through it 2 times. So we are here, right? So we look at the gain. The gain now is -2, right? So we have 1 gas, and to get to the next station, we need to cost 3 gas unit. So the current gas will be -2. The total gas will be -2, right? And we start at station 0, right? Like index 1, 2, 3, 4, 1, 0, 1, 2, 3, 4, right? And because current gas is negative, right? Which means it cannot get to the next station. Well, if it cannot get to the next station, it means that there's no point of starting at 1, right? We should reset the starting station to the next station, like to station 1. Reset our current gas to 0, right? And keep trying. Right? So next, our net sum or our gain will be also be -2, right? Total gas should not be -4, and because it is negative, right? The current gas in the tank is negative, which means if we start here, we cannot get to the next gas station, right? So there's no point of starting here. So we set our current gas back to 0 and update our starting position to the next station, right? Same case here, our current gas to be -2. Total gas is accumulative, so it becomes -6. It is total gain, right? Total gain. A total gas, like after you travel all across all station. So it is negative, so we start back to 0 and we move on to try the next station, right? Because we cannot get from station 2 to station 3 if we have a negative net gain. Okay, so now we are at 4. The gain is 4 minus 1, right? Which is 3. So the total gas become -3, right? The current gas become 3, right? So it does indicate that we are able to get from station 4 to station 5, right? So we keep going, right? Our starting station, we just stay here, right? The beginning index, the index of the beginning of the maximum subarray, right? So we move on to here. Then again is 2. Oh, sorry, 3. 5 minus 2 is 3. So the total gas becomes 0, and the gas becomes 6, right? And we are done here. So because the total gain is greater than or equal to 0, right? Which means they exist a valid solution, right? And our starting station would be 3. Because starting at 3, will give us the most amount of gas, right? It makes sense, right? Because if you start from 3, you have 6 here, right? And in order to get back to 3 again, you need to go through 0, 1, 2, right? And 0, 1, 2 again is -6, right? So you just have just enough gas to get back to station 3. Right, so if at any point, again, if at any point, our gas is falling below 0, right? Which means we cannot get to the next station. So um, there's no point at starting from that station. We'll just try the next station. Um, and yes, because there's only one solution, so we know that if um, station 3 was able to get to station 4, right? There shouldn't be any intermediate station that can get it from 3 to 4 because they only exist like a unique or only one solution, right? Okay, so that is our general algorithm there. You can do is in so let's call this up. So we're gonna have our total gas rate in your tank. Just for short on total gas. Right, we can just return. So if the total gas is less than zero, right, we just write return -1. If it is greater than or equal to zero, right, we will return the starting station. Okay, so why the starting station is no, not. So we need to, what do we do? We need to iterate the gas. Okay, and then current gas equal to plus equal to the gas at this station, which is gas of I, right, and minus the cost at the next station, which is cost of I, right? Total gas gonna be the same. And if the current gas is equal to less than zero, right? It's drop below zero, we want to set the current gas back to zero and reset the starting station right equal to average. Let me see if we're missing anything here. So we have the current gas, we have the total gas, and then we update them, right? Add the current gas to the total gas as we iterate through the array, so we don't have to do it in two pass, right? And then if the current gas is ever drop below zero, which means we cannot get to the next station. So in that case, we want to reset the current gas to zero, right? And try starting at the next station, which is I plus one. Makes sense. Okay, so let's try this. The display complexity would be constant, and it worked. Thank you for watching.